Again, molarity is how potent a solution is. And it gives you an equation in word form. This is the abbreviation for that equation. Capital M is what molarity is. Molarity is the moles of solute. Now let's remember our vocabulary since we're talking about solutions. Solute is the thing being dissolved. So 2% milk, that 2% is referring to the fat part of the milk. Per liter of solution. So how much kind of active ingredient do I have in a total volume? What we're going to be going over here with this how-to sheet is how to solve for molarity in questions like this. But we can solve for other things as well. We can solve for the moles. We can solve for the liters. And because we can solve for any of those three variables, similar to what we showed you with density at the beginning of the year, some students aren't really comfortable with algebraic manipulation. So I show them this little triangle. This triangle shows you how to solve for any of these three variables. So for example, if you wanted to solve for molarity, which is capital M, you put your hand over it, it's moles over liters. If you wanted to solve for moles, you put your hand over it, it's molarity times liters. If you wanted to solve for liters, it's moles divided by molarity. Now some people are good enough with the algebra with this original equation that they don't need that little trick. But if it helps you out, great. What I'd like to do is question number 1 on this how-to sheet. So let's skip the example, because you can always look at that on your own. Question 1 says, what is the molarity of a 5,000 milliliter solution containing 22.95 grams of KBr? Question number 1 is asking us to solve for molarity. And that's the first 4 words. What is the molarity? In order to solve for the molarity, I need to have the moles of the solute and the liters of solution. And when I look at the rest of the numbers in that problem, I don't see either. I don't see a mole value. I don't see a liter value. So it's going to take a little bit of work to get to this. How can I find the moles of solute? Does anyone know? Convert grams to moles. Remember I told you needed your periodic table to start this? So, if I have 22.95 grams of KBr, I can use my periodic table to convert from grams into moles. Doing a mole conversion. Mole conversion is something we taught you first semester. It will not go away. You're going to see it in the next unit as well. So you look up the mass of K on the periodic table, 39.1. Look up the mass of Br on the periodic table, 79.9. I'll help you with this number, 119. Let's have someone with a calculator give me this answer with 4 significant digits. There's 4 sig digs in this value here. And kind of ignore the conversion part because it's 119.00. That ever wrong? Yeah. 1929. Okay, so I have my number of moles. I also need my number of liters of solution. I'm not given liters. I'm given milliliters. So Kaylee suggested I convert grams to moles to get moles. I can convert milliliters to liters. What's the relationship between milliliters and liters? What numbers do I put in this conversion? Come on, we got to remember milliliters to liters conversion, don't we? How many milli in a base unit? Hey, Allie, if you know the answer, say it louder. 1,000. There's 1,000 milliliters in a liter. Ladies and gentlemen, if we actually don't know that, instead of us just being shy, if we don't know that, we are in trouble. Because that is the easiest thing that we are doing today is a metric conversion. So either you just don't want to speak up, okay, fine, or holy cow, my job is about to get difficult. Because if we don't know a metric conversion, whew, mole conversions are a lot more difficult than that. Because you know what I was going to tell you? By the way, if you divide 5,000 by 1,000 in your calculator, I'll come around, I'll smack you in the head. 5,000 divided by 1,000 is 5, like you know. Here's what I was going to tell you before there was deafening silence when I asked you the easiest question of the day. Whenever you do math, we require that you show your work, because showing your work demonstrates that you understand what's going on, as opposed to just looking at someone else's paper or I typed into my calculator, isn't that good enough? All three chemistry, I guess four now because with the Schaefer, chemistry teachers have agreed that this conversion we don't have to see. If you can do milliliters to liters in your head, I will accept that. So in other words, you don't have to show that step. I highly doubt you can do grams to moles in your head dividing by 119. You better show that value. But we have accepted at this point that what should be easy for us is milliliters to liters. Now, I have a mole value, I have a liters value. Molarity is moles divided by liters. 0.19, did you say 29? Divided by 5.000. 4 sig digs, by the way. Both numbers have 4 significant digits. The zeros after a decimal are significant if there was a number involved. This we would need a calculator for. Anybody? Go, Belle.
0.03858.
The unit for molarity is a capital M. She was correct as well when she gave you the number of significant digits. These zeros to start are not significant. You don't start counting sig digs until you hit your first non-zero number. Now let's say instead you had 0.03857. That's fine. Remember, there's going to be little differences in rounding as we're doing this. I can accept that. So this would be the final answer. On a molarity question like this, by the way, because you will see this on your quiz next week, 1 point is for doing moles divided by liters. 1 point is for the final answer, of which a quarter point's taken off if you do not include this capital M for molarity. A quarter point's taken off if you're wrong on sig digs. But there's also going to be a point for doing the mole conversion. So this would be a 3-point problem. So again, here are the answers to questions 2 and 3 on that sheet on the front side. What I'd like to do is have you flip to the back side right now. Knowing how to solve for the molarity of a solution is an important skill. But probably what's more common is to figure out how many grams of a solute that you need. So usually what happens is I know how much solution I need. I know the volume. I know the molarity that I want. How do I make it? So if I go back to our original equation, capital M, molarity is moles per liter. And if I go back to our triangle on the right side of the slide, the back side of this how-to sheet is my opportunity to try to solve for grams. And even though grams isn't in this triangle, grams and moles are related to one another via the periodic table, doing a mole conversion. So what we need to practice now is solving for the grams of solute. So if I want to make a certain molarity of solution, how do I do it? So again, on the back side, I'm going to do question number 1 with you right now, and then you guys can work on 2 and 3 for a little bit. Number 1 says, how many grams of rubidium iodide are needed to create a 1,950 milliliter of 0.27 molar solution? To me, the very first thing we should do is whenever you see a chemical in word form, rubidium iodide, figure out the formula. Maybe write it right above the word form. So when it said rubidium iodide on it, what I would do is figure out the formula. So Tristan, what's the charge on rubidium?
+1.
Rubidium's a +1. Hudson, what's the charge on iodide? Logan, what does that make the formula rubidium iodide? RBI. Probably helpful in this. Now again, looking at the question, how many grams? The first three words tell you what you're trying to find. You're given milliliters and you're given molarity. If I go back to my triangle, if I want to solve for grams, I first need to get to moles. And if I cover up my triangle, to get to moles, I'm going to take molarity times liters. So, the molarity given to me in this question is 0.27 molar. The liters given to me, 1.95. I'm not going to include that other 0 because there wasn't a decimal after it, so there's my liters. Molarity times liters equals moles. Now you could report it with 2 sig digs, or you can just keep your calculator running. For the purposes of practicing sig digs, how about you give this to me with 2 sig digs there, Maya?
0.53.
0.53. Now that I know my moles, and I know the formula of RBI, I can convert moles to grams. So 0.53 moles of RBI. If I want to convert to grams, that means grams should be on the top of my conversion. If I want to get out of moles, moles should be on the bottom. There's always one number that you put in front of the word mole, the number 1. And then it's a matter of, look at the mass of RB, look at the mass of I. I'll give you that value. 212.37. Since the number's in the numerator of the conversion, that means we're multiplying, and hopefully all this makes sense to you. Once again, we should only have 2 significant digits in our final answer. Does someone have a final answer for me? Go ahead, Bella.
112.5.
So if it's 112.5, how do we round that to 2 sig digs, since this only has 2 sig digs? Anyone? 110. Yep. I know you guys don't like rounding off things before the decimal place. The rules of significant digits are in place because a final answer not only demonstrates a quantity, an amount, it also indicates the type of equipment that was used to get those measurements in the first place. Just like before, let's give you a chance to work on 2 and 3. I'm going to write the final answer to both of those down right now. And again, I'm abiding by significant digits, so if you get a slightly different answer, that's probably the reason why.